right, here is the key to your test review. It says for each function family below, give the equations of parent function, bad wording, sketch the shape of its graph, then state whether the function is even, odd, or neither. All right, so I'm going to sketch them first. There's my linear. There's my absolute value. There's my quadratic. There's my cubic. Here's my square root. And here's my cube root. Okay, so I'm also going to put my anchor points on there. These are those anchor points. I got 3 anchor points for the absolute value. I have 5 for the quadratic. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Cubic, got 0, 0, 1, 1, negative 1, negative 1, 2, 8, negative 2, negative 8. Square root, 0, 0, 1, 1, 4, 2. Cube root, 0, 0, 1, 1, negative 1, negative 1, 8, 2, negative 8, negative 2. All right, so the equations, linear, f of x equals x equals x. Well, you know what that says. Absolute value, f of x equals absolute value of x. Quadratic, f of x equals x squared. Cubic, f of x equals x cubed. Square root, f of x equals the square root of x. Cube root, f of x equals cube root of x. All right, so then I also have to state whether it's even, odd, or neither. So a linear is odd because it has origin symmetry. Absolute value is even because it's symmetric with the y-axis. Quadratic is even because it's symmetric with the y-axis. Cubic is odd because it has origin symmetry. Square root of x is neither because it has neither. And then cube root is odd because it has origin symmetry. Okay. Now let's check out the piecewise function. Sorry about the extra little lines. I moved stuff and didn't see those lines. All right, so I'm going to evaluate. So on 7 through 8, or on 7 and 8 I'm using this, but on 7 I'm just evaluating. So I want f of negative 7. Well, negative 7 falls in this domain because negative 7 is less than negative 3, so that means I'm substituting it in right here. So I'm going to have negative and then negative 7 plus 5 cubed plus 4. All right, so negative 7 plus 5 is a negative 2. So I get negative 2 cubed plus 4. So negative 2 cubed is negative 8. Negative 8 made negative is positive 8. So 8 plus 4, I get f of negative 7 equals 12. All right, so then f of negative 4. So negative 4 falls in the same domain, so I'm using that same first subfunction again. So I'm going to get negative 4 plus 5 cubed plus 4. So that's 1 cubed is negative 1 plus 4. F of negative 4 equals 3. Sorry, pen's being stupid. Okay? All right. So then I'm supposed to graph this same piecewise function and then give the domain, range, and identify the location and types of discontinuities. All right. So the first thing I'm going to do is I need to find my endpoints here, right? So this is a cubic. Looks like this. Right. And I'm going to substitute in my negative 3. So negative 3 plus 5 is 2. Cubed is 8. That makes that negative 8 plus 4. is going to give me -4. So I go to -3, 1, 2, 3, -4, 1, 2, 3, 4. And that's going to be an open circle because this is just less than. Okay, so then I'm going to graph using my anchor points. That's why I plotted these anchor points up here. Right? My first one would be at 0, 0. So I'm going to put my pencil at 0, 0. This means I go to the left 5, up 4, and I reflect in the x-axis. So I can't reflect if I'm at 0, 0, so I go to the left 5, 5, 1, 2, 3, 4, 5, and up 1, 2, 3, 4. So there's that. Okay, so then my next anchor point is 1, 1. So I go to 1, 1. I reflect in the x-axis, move to the left 5, 1, 2, 3, 4, 5, and up 1, 2, 3, 4. Then I go to -1, -1. Put my pencil there, reflect in the x-axis, go to the left 5, and up 4. I'm here. My next anchor point is at 2, 8. So I go to 2, 8, 2, 4, 6, 8. I reflect in the x-axis, move to the left 5, and up 4. So I'm there. So -2, -8. Once I am here at -2, -8. And then I reflect in the x-axis, move to the left 5 and up. I'm way off the graph, so that's really all I can do here. So this is going to look something like this. Well, let me do that again. Sorry, just making a shadow on myself here. Something like that. All right. Expect to see the anchor points you can do. So then I have 2 endpoints here, so I'm going to take that -3 and substitute it in here. -3 squared is a +9. Make that negative. That's -9 plus 2, which is -7. So I'm going to go to -3, -7. 2, 4, 6, 7. And that's closed. Oh, stupid pen. Of course it's not going to cooperate. Okay, and it's closed because it's less than or equal to. Then I take the 2 and I substitute it in there. So 2 squared is 4, make it negative, that's -4, plus 2 is -2. So I go to 2, -2, and that is an open circle. Okay. So this is a quadratic that is reflected in the x-axis and moves up 2. So I'm at 0, 0. Reflection doesn't do anything, and I go up 2. Then I go to 1, 1. I reflect in the x-axis and move up 2. So I did 0, 0, and 1, 1. I got to go to -1, 1. I reflect in the x-axis and move up 2. Then my next one is at 2, 4. So I go to 2, 4. I reflect in the x-axis and move up 2. That is that point. And so I can use symmetry, and I got this other point here. So this section looks like this. Then I have just one endpoint here. I take the 2 and substitute that in. So -1 minus 2 is -3. So I go to 2, -3, and that is a closed circle. And then this is just a line. It has a -1 for slope. So if it's negative, it's going like this. So I just need to go 1, 1. There's my point. Then I can draw that section of the line in. Oops. I missed. Something like that. Okay. All right. So then my domain. I start way out here at -infinity. And as I go along here, I'm using all of the x's all the way to infinity. That's good. My range, I start down here at -infinity. And I go all the way up to infinity. No breaks or anything. So I do have discontinuity here. I have jump twice. So I have jump at x equals -3 and x equals 2. All right. So now it says, if the quadratic parent function, okay, so my quadratic parent function is f of x is equal to x squared, okay, is reflected in the y-axis, so that means the negative has to affect x, and vertically compressed by a factor of 1/2. Write an equation to represent the new function. Okay, so we got quadratic parent function, that's that. Reflected in y-axis, vertically compressed by a factor of 1/2. So there's two transformations, the reflection and the vertical compression. So that would mean that I would have like g of x equals, so the vertical compression happens outside of the square, so that's going to be a 1/2. That affects y, and y does not lie. And then if it's reflected in the y-axis, then that means it is the negative affects the x before you square it. So that's what it would look like. Okay. Then we have the cube root parent function, f of x equals the cube root of x. Okay, it is, so I have that, horizontally stretched by a factor of 1/4. Okay, I messed up on this. You cannot horizontally stretch by 1/4. That is a compression. I missed that and I meant to fix it and I didn't. So if you say stretched, it has to be a stretch. So this would have to be more than 1. If you say compression, this has to be less than 1. This should say compressed. So it's horizontally compressed by a factor of 1/4. Then translated 5 units right and 3 units up. We're going to write the equation of the new function. All right. So I have, how many transformations? I am horizontally compressing it by 1/4, translating 5 units right and 3 units up. So there's 3 transformations there. So since I'm horizontally doing something that's under the cube root, it's inside with x. So I'm going to cube root, and then x lies, so if it's a factor of 1/4, it really is going to be 4x, okay? But I'm going 5 units right, so I have to open my parentheses here, and again, x lies, so it's going to be minus 5, and then outside of this, I'm going to have plus 3. Okay. All right. Number 19. Describe all the transformations from the parent function given the function below. All right, so let me figure out how many I have. I have this negative, and I have this 3, and I have this 1/2, and I have this 7. So I have 4. I'm going to list 4 of them. So I'm going to put 4 little bullet points here. So I'm going to start with this negative. This negative happens after you cube it. So it's still a reflection, but it's a reflection in the x-axis. Okay? It affects y, you reflect an x. Then I have this 3. Again, it's outside the cube, so that makes it a vertical stretch by 3. You can't just say a stretch by 3. Is it vertical or is it horizontal? Then I have this 1/2. It's being multiplied in here, but x is a liar. This is horizontal. That's not what it's lying about. Looks like it should be a compression, but it's a horizontal stretch by 2. And then we go up 7. All right, number 20. Again, I have 1, 2, 3, 4 transformations. So 1, 2, 3, 4. This 2/3 being multiplied outside of the square root. So that means that it is a vertical, and this is less than 1, so it's a compression. So it's a vertical compression. Oops, not a compression by 2/3. This negative is a reflection, but it's inside here, so it's affecting x, so it's reflecting in the y-axis. Then this 5 means I go to the right 5 and up 2. All right, so now we're going to determine whether the function is even, odd, or neither. Prove your answer algebraically, and it should also say if it's even or odd, to state what type of symmetry it has. It does not say that here. It will say it on the test. So in order to do this algebraically, I do f of negative x, and I substitute in a negative x everywhere. That's equal to negative 3 times negative x. Oh, this pen. Negative x cubed plus 5 times negative x. All right? So negative x cubed is negative x times negative 3 is going to be 3 x cubed minus 5x. So this is f of negative x. So at this point, I ask myself, does this look identical to this? And the answer is no. So that means it's not even, because if f of negative x, remember that if f of negative x equals f of x, that makes it even. And if f of negative x equals negative f of x, that makes it odd. Okay? So since it doesn't, I need to see if it's not going to equal f of x, so I need to see if it equals negative f of x. So I factor out a negative, and I get f of negative x equals negative, and if I factor out a negative, that leaves me with negative 3x cubed plus 5x. And then when I look at this is identical to this, and so this is negative f of x, so that means I say f of negative x equals, oh my gosh, these equal signs, equals negative f of x, and that means that this is odd, and it has origin symmetry. Okay. So let's try 33. Got f of negative x, that's equal to 5 times negative x squared plus 2 times negative x minus 1. So f of negative x equals, so negative x squared is x squared, so I got 5x squared minus 2x minus 1. So I look and see, does this match this exactly? The answer is no, so it can't be even. So then I factor out a negative. F of negative x is equal to negative, and then I have, that would leave me with negative 5x squared plus 2x plus 1. Then I check, does this match this exactly? And the answer is no. So it's not even or odd, it is neither. All right, other side here. We are graphing a function, and you have to write the parent function. So I will say again, the parent function has 3 parts to it. It has what you would say, okay, this is a quadratic. F of x equals x squared is the parent function, and that's my little sketch. All 3 of those parts are important. Okay? Whether or not you write out your, or you should write out your transformations. So let's do that. I've got this 2 means that I have a vertical stretch by 2. This 3 means that I go to the right 3. And the 4 means that I go down 4. So I'm going to use my anchor points. I start with 0, 0. Notice I'm not making a t-table anywhere. Some of y'all had crazy stuff all over your quiz. I don't know what you're doing, but you're not doing what I taught you, and you're probably not going to get any of this right. Because I'm looking for specific, you have 5 anchor points. You got to graph them all. So start at 0, 0. Vertical stretch doesn't do anything. Then I go to the right 3, and I go down 4. Boom. Then I go to 1, 1. 1, 1. Vertical stretch by 2. That means I multiply my y value by 2. My y value is 1. It becomes 2. Then I go to the right 3. 1, 2, 3. And I go down 1, 2, 3, 4. Then I'm going to go to negative 1, 1. And then I have a vertical stretch by 2. So my 1 becomes 2. Then I move to the right 1, 2, 3, and I go down 1, 2, 3, 4. That's only 3 of my 5 anchor points. My next one is at 2, 4. So I go to 2, 4. Vertical stretch by 2, so I have 4, I multiply that by 2, I get 8. Then I move to the right, 1, 2, 3, and down 1, 2, 3, 4. Then I have negative 2, 4. So I'm at negative 2, 4. Multiply my y value by 2, I get negative 2, 8. move to the right, 1, 2, 3, down 1, 2, 3, 4. So those are my 5 anchor points, and I can sketch in, oops, man, it's way easier to do on a piece of paper than this board. Okay, close enough, just to make my point bigger. Your anchor points are what I'm really looking for, that you actually tried here. Okay, so my domain, negative infinity to infinity. My range, I start down here at 1, 2, 3, 4. At negative 4, which I include, and I go to infinity. My x-intercept, I have 2 of them. Don't know what they are, so I've got to find them, right? And I didn't give you a whole lot of room for that, so I think I'm just going to write, let's see, can you read that if I write on? I think I'll just write on top of that. So my x-intercept is when y is 0, so 0, 0 equals 2 times x, that's terrible, you can't read that. Maybe you can, I can't read it on this. Okay, I think maybe I can do that one. All right, so 0 equals 2 times x minus 3 squared minus 4. So add 4, I get 4 equals 2 times x minus 3 squared. Divide by 2, I get 2 equals x minus 3 squared. Then I take the square root of both sides. So on the left, I get plus or minus the square root of 2 equals x minus 3. So x is equal to plus or minus the square root of 2 plus 3. So I have 2 x-intercepts. That's why I have that plus or minus. So it is plus or minus the square root of 2 plus 3, comma, 0. Those are my 2 points. Then my y. Maybe I should just do this. Maybe we can read this one. My y-intercept is when I get f of 0. That is 2 times 0 minus 3 squared minus 4. So that gives me 0 minus 3 is a negative 3. Squared is a positive 9 minus 4. So that's going to give me f of 0 equals 18 minus 4, which is 14. And that should make sense. It should be big up there. So this is at 0, 14. Okay. My critical points, I have an absolute maximum, an absolute minimum at 1, 2, 3, 1, 2, 3, 4, 3, negative 4. Oh my gosh. And then I'm increasing starting here, and that's at x equals 3. So I'm increasing from 3 to infinity, and I'm decreasing from negative infinity to 3. My end behavior as, this board is driving me nuts, as x approaches infinity, f of x approaches, so as x gets bigger and bigger and bigger, so does y. F of x approaches infinity. And then as x approaches negative infinity, f of x approaches infinity also. All right, next one. So here, this is a cube root. F of x equals the cube root of x. And this is a parent function. I'm going to list off my transformations. I have a vertical stretch by 2 again. Then I'm going to the left 4, and I'm going up 3. Okay, so I'm going to start at 0, 0. That's this anchor point. Vertical stretch doesn't do anything. I go to the left 4 and up 3. Boom, there's my first point. My next anchor point is 1, 1. I have a vertical stretch by 2, so my y value becomes 2. I go to the left 4, 1, 2, 3, 4, and up 1, 2, 3. Oy. Oh my goodness. Okay, I lost where I was because of my stupid board. All right, let me do that again. 1, 1. Vertical stretch by 2. Go to the left 4, and up 3. I have a point right there. Then I'm going to go to negative 1, negative 1. Negative 1, negative 1. My pencil there. Vertical stretch by 2, so my y value becomes negative 2. Then I go to the left 4 and up 3. All right, so my next anchor point is 8, 2. That's not magic. I didn't memorize it. Well, I mean, I kind of did, but it's what's the next x value that gives me a decent y value? I have to take the cube root of 8 to get 2. So I go to 8, 2. Then I vertically stretch by 2, so now I'm at 4. I move to the left 4 and up 3. I'm right here. So then I go to negative 8, negative 2. Vertically stretch by 2, I'm here. But then I move to the left 4 and up 3. So I'm like way far off my graph. So I don't need to do that one. What I do need to do, however, is think about what my little parent function looks like and the fact that it's laying down. So coming up like this doesn't make any sense. This comes in like so. My domain, negative infinity to infinity. My range, negative infinity to infinity. My x-intercepts. Okay, so let me come over here. X-intercept is when y is 0. 0 equals 2 times the cube root of x plus 4 plus 3. So I'm going to subtract 3, and I get 2 times the cube root of x plus 4. Then I divide both sides by 2, so I get negative 3 halves equals the cube root. Notice I did not put 1.5 or 1 1/2. Cube root of x plus 4. So in order to undo a cube root, I'm going to cube both sides. When you cube a fraction, it's super easy. You cube the numerator, you cube the denominator. When I cube a negative, it stays negative. So this is going to be negative. 3 cubed is, 3 times 3 is 9 times 3 is 27. 2 cubed is 8. That's equal to x plus 4. So then I'm going to subtract 4 from both sides. So x is equal to negative 27 over 8 minus 4. And once you do your fraction magic, you get negative 59 over 8. So it's negative 59 over 8, comma, 0. So my y-intercept, let's see, I'll do that one in here. That is f of 0. Give myself a little more room. F of 0 is equal to 2 times the cube root of 0 plus 4 plus 3. So that gives me 2 times the cube root of 4. Cube root of 4 is not, I don't know why my 2 is so little. 2, okay, this is just stupid. 2 times the cube root of 4 plus 3. And that's really all I can do. So it is 0, 2 times the cube root of 4 plus 3. Critical points. I have a point of inflection at negative 4, 3. I'm increasing everywhere, negative infinity to infinity, because a point of inflection does not change from increasing to decreasing. And then I say, as x approaches infinity, f of x approaches. So as x gets bigger and bigger and bigger, so is y. So it's approaching infinity. And then as x approaches negative infinity, f of x approaches, well, as x gets smaller and smaller and smaller, so does y, negative infinity. All right. Almost there. Okay, so I've got to identify the domain and range of each graph below and state the location and type of any discontinuities. All right, so here, my domain, I've got arrows here. So as I start out here at negative infinity, go along until I get to negative 3. So I'm going to go from negative infinity, and then at negative 3, I do have this jump discontinuity, but it's also missing a point here, so I don't have an x value at negative 3, so I don't get to include it. But then I start back over on the other side of negative 3, and I keep going. This is fine because that x value is taken care of, but here I have an asymptote, so that's at 5. So I go to 5, and then I keep going, a union, and I start back over at 5, and I can go to infinity. All right, so my range, I start down here at negative infinity. As I go up, all my y values are taken care of all the way to infinity. So my discontinuities. Here I have a jump, but I also have a hole, right? Because on the other, like this is jump, but one of them is filled in. So I've got jump and hole. So I've got, I don't call it, it's not hole discontinuity. It's point discontinuity or removable discontinuity. But I'm going to say point and a jump at x equals negative 3. And then I just have jump at x equals 2. And then here at x equals 5, I have infinite. X equals 5. Sorry, my handwriting is even worse because my pen is really just being stupid. All right. So then I have arrows here and here. So my domain, I start out here at negative infinity. All of my x's are accounted for all the way to infinity. Then my range, I start down here at negative infinity. And all of my y values are taken into account until I get to here. And that's at 6, but I don't include it because it's an open circle. Okay? But this is not point discontinuity because I'm not missing a point here. Notice that. My discontinuities here, this is jump and this is jump. So I have jump twice. And it happens at x equals negative 2 and x equals 1. All right, one last graph here of a piecewise function. So we're going to graph this function. All right, so I start off by taking this negative 4 and substituting it in here. So negative 3 halves times negative 4 would be like a positive 12 halves, which is 6. And 6 minus 6 is 0. So I go to negative 4, 0, and that's an open circle. This is a line. This is linear. So it's just this right here. My slope is negative 3 halves. So since my slope is negative, I know it goes this way. So from this point, I'm going to go up 1, 2, 3, and I'm going to run to the left. There's my other point. And there's my line. Okay, so then here, I'm going to take the negative 4 and substitute it in here. So the absolute value of negative 4 is 4, but then you make it negative, you get negative 4. So I'm going to go to negative 4, and that's a closed circle. Then I'm going to take this 1, and I'm going to substitute it in here. Absolute value of 1 is 1, but then we make it negative. So I'm going to go to 1, negative 1, and that's also a closed circle. This is an absolute value function, and I'm going to graph it just like I would if it wasn't a piecewise. I just know that these are my boundaries. I can't go on either side of that. So I'm going to start with 0, 0. Put my pencil there. The only thing that's happening is a reflection in the x-axis, so I don't go anywhere. Then I go to 1, 1. That's my next anchor point. I reflect in the x-axis. Boom, I'm right there. Then I go to negative 1, 1. Put my pencil there. Reflect in the x-axis. Boom. Absolute value only has 3 anchor points, so I'm done. And there's no arrows on that because that has a boundary on both sides. Okay, so then I take this 1 and I substitute it in here. 1 minus 1 is 0. Square root of 0 is 0, so I get 1, 3. 1, 1, 2, 3. And that's an open circle. This is the square root function. Looks like this. So I start with 0, 0. Put my pencil there. My transformations are that I go to the right 1 and up 3. So with the right 1, up 1, 2, 3. Well, that point's already there. So then I go to 1, 1. Put my pencil there. Move to the right 1 and up 1, 2, 3. There's that second point. My next point is 4, 2. Then I move to the right 1 and up 1, 2, 3. And then this is what my square root looks like. Okay, so then I have to state my domain. So I start out here at negative infinity. All that's taken care of all the way to infinity. So negative infinity to infinity. Range. I start down here at 1, 2, 3, 4. At negative 4, which I include. And then I go all the way up to infinity. Discontinuities, I've got jump twice. Got it at x equals negative 4. And x equals 1, which again is where we change here. Okay, so that's that. Make sure you were prepared for this test. That also means maybe looking back over the quizzes that you got back, looking over your notes, doing some Delta Math redos, or doing it for the first time, because a lot of you haven't. And I'm quite sure that's going to be evident tomorrow when I grade these tests. So be ready for this. You can do well, and I'm also grading your ISNs.